For this video, we move another new module, not module because this is still under module 2, but we are moving to a new section. So what we're going to learn in this video is very easy because this one is only about arithmetic operation. All of you already learned on mathematics, I think, for your primary and then secondary school. All is quite related or similar. So what you're going to learn, which is I said it's very easy because it is additions and subtraction operation. Tambah tolak. It is just a basic mathematics, isn't it? But a bit different because we are dealing with the signed numbers and also unsigned number, and later on you will see that there is also that you're going to learn on another new form of numberings. Later on you're going to see, but first I don't want to reveal it. Let's just learn the basic of operation under arithmetic. So first we already know that integer number there is unsigned and also signed number. This one also I already touched a bit on numbering system. If you didn't remember, please go back to previous video, and I think in the beginning chapter of number system, I already give you the differentiation between number system. You look that there is unsigned and also signed numbers. So here we look again, but a bit deeper. So let's look over here. Integer representations. So number can be represented as a combination of value or magnitude and also sign plus or minus. So you can see over here there is value or magnitude and sign, which is positive or negative, and then plus or minus operation. So first you need to have a value. Let's say it is a 1, 2, 3 and etc. This is a value or magnitude. And what you need to know, what you need to have is and sign. Either it is negative or positive, plus or minus, and that over here you can see whether the operation is plus or minus. It depends on what is the representations, and the sign is also on the integer sign. And you have basically whether it is an unsigned integer or it is a signed integer. For unsigned integer data, so what is unsigned integer data is which is the value with no negative. Means that all values which is no negative value, which is starting from 0 until up to infinity, it is a unsigned integer numbers. And this one you already learned, which is bit, byte, and then you learn also word and etc. words in the next slide. So over here you know that a bit can be stored unsigned integer. So you can see over here bit can store unsigned integer, which is from 0 to 1. Because what? Bits only have two possibility, which is 0 or also 1. This one, if you didn't remember and you did not understand, please go back and find the video about, I think still under this number system, which is we learn on bit, byte, word, and etc. So over here, after bit, we know that there is a byte. So byte consists of 8 bits. Byte consists of 8 bits and can store unsigned integer from 0 to 255 only. So this is the equation, the maximum value for each of system. Let's say for byte. For byte, it is normally, you know that byte is 2. And then over here you have this one is the equation for you to get the maximum value for each system, which is whether it is a byte, words, and etc. So this example, this one is for byte, which is normally byte having 8 bits, which is 2 the power of 8 minus 1, you will get to 5. Is it okay? So next, I did it first. Okay, this is the possibility, because you have 0, 0, 0, which is 8 bit. 8 bit, and then similar to here, the possibility which is you can count from 0, 0, 0, 8 bit and until up 1, 1, 1, 1, 1, and this value is basically 255. So you're going to use the equation over here. The equation is not yet shown, but it's okay. But this is the equation that you're going to use. Later we will look into it. So next is on word. So this one is word. Word, you know that it contains 16 bits. So 16 bits, which is you're going to use this equation to the power of n minus 1, or equal to the power of 16 minus 1. Then you get this value. Or if let's say you're using the numbering system, you can see that it is like this, because it is 16. So you calculate 1 until 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there is 16 bits over here. So the maximum number is 65535, and the minimum value for all is 0. So the range of number depend on, here now it come the equation. So the range is from 0, everything is starting from 0 to this equation to the power of n minus 1. The positive numbers range is from 0 to the power of n minus 1. Example, find the range of binary numbers that can be represented by 10 bits. So it's easy. You need to know the range. So first of all, you know that the minimum will be 0, and it will be until to the power of n minus 1. So over here, we change it to the power of 10. Why 10? Because it is 10 bits. You minus 1, you're going to get the value. So the value of to the power of 10 minus 1, you will get 1023. So this is the range for in form of binary number that represented by 10 bits. Over here, this is still under unsigned number, which is you have a upper and lower bound. If let's say you have 4 bits, lower bound, which is the minimum, as I mentioned, it always start from 0, isn't it? So it start all of from 0, and the maximum or upper bound. So don't feel like, what is upper bound? Because normally you said the range is from minimum to maximum number, right? The maximum range and the minimum range. But there is also another words that represent as minimum and maximum, which is lower bound and also upper bound. So don't feel and say that you didn't heard about this before. If there is a question saying that about please state the upper bound for number of 4 bits. So you know that upper bound is maximum value within the range, and lower bound is always 0. Lower bound is minimum. So the range is 0 until 15. Over here, why is 15? Because to the power of n minus 1, which is 4 over here, the power, etc. You can try by yourself also. This is just about, I think, more theory also. On the calculation part, it's just when you apply it into the formula or equation. Example. So find the lower and the upper bound. So here, I already told you there is a question like this about lower and upper bound. So this is a minimum and also maximum, and we can say also range of 12 bit. So it's quite easy because just a small one, small thing that you just need to remember, which is about the equation to the power of n minus 1. And then you have 2 the power of n, which is 12, and then you minus 1. So you will get the range of the numbers. So you can say that lower bound is this one, upper bound is this one, and therefore the range is 0 to 4095. You calculate it by yourself. And now we move to the signed numbers. So signed numbers, what is the difference? It's only on the, it has positive and negative. For unsigned, that we already looked into, if you can see over here, unsigned number, you have only positive value, which is no negative value. Now when you go back to when you move to a new section, which is under signed number, you will see that signed number, it's got positive and negative value. So this is the example positive and negative value in terms of binary or base 2. And then positive and negative integer can use a code system to indicate the sign. If let's say sign is positive, it will be a 0. Negative, it is a 1. This one is a signed numbers, which is you put this sign whether it is a positive, which is 0, and then for 1 it is a negative. Add the MSB. Let's say over here you have this number and you will put this 0 in front as to assign it as a positive number, and this one is a negative number because of in front of it there is a 1 over here. But you need to know that basically in question they will stated how many or what is the bits of the numbering. If let's say the bit number is 2455, then you add it in front as 0. I give you example. If let's say you have it give you 4 bit number, 4 bit of number, let's say I give just example 4 bit, so maybe they give you 0 1 0 1. This is the number given, so it stated this one is positive number. How are you going to represent it? Or maybe it give you the negative number. So if positive, you just add it 0 over here, and negative, how? You put 1, isn't it? So this is easy example. How about if let's say you were given 4 bits but the number is 1 1 0. So over here, if let's say you want to assign is a positive, you need to add 0 over here, and then if let's say it's 1, you need to put if let's say it's negative number, you need to add this 0 in front because it is 4 bit. You just given like this, but it mentioned it is 4 bit, so you know there is a 4 bit which is over here should be 0. Then later you can add what is in front of this number, whether it is positive or this is a negative. Is it okay? So this is only for sign number, because after this you might confuse how to change on give you later I talk about it, because I want you to focus on sign number first. So let's move to another example. For positive it is 0 and negative is 1. So the example is you are given this number, so following this decimal number you need to represent its binary representations. So 4, you will get this, so you will put 0 1 0 0. This one is represent as positive. And how about 12? 12 if 1 1 0 0, so you add another 1 in front as a negative. And this one you can also try it by your own. Determine if the bit binary numbers is positive or negative. You were given this one, and sign number 0, for therefore number is negative positive, and 1 here in front, it is a negative. So how about the value in decimal? This is happen, and I mentioned to you that over here there is a 0 0. See, in the previous example. So this is negative 3, and then this is a positive 17. So please try this example. So here is the count that you're going to feel a bit confused, because this one was mentioned for you in the sign number. You just need to put 0 or 1 in front of the binary number. as to state whether it is positive or negative. But here, when you play around with this sign number representation, especially on the complements, you might be a little bit confused, but just focus on this. I think you can just go through. It's quite easy if you really understand and just apply the equation. I think so. So there is 3 representations on the sign number. First of all, sign and also magnitude, which is simple representations that you already learned in previous, which is 0 is positive and negative is 1. So this is a simple representation. And then you're going to learn on first complement and second complement. Now, let's take a look on the what is a first complement and second complement. Before that, this one is you already learned in on your unsigned also. Still similar equation. Simple and fast, which is lower bound, the minimum one, and the upper bound is using this one. The minimum is unsigned number is 0. But for signed number, the lower is negative to the power of n minus 1 minus 1 again. So the equation quite different, where n is a total bit. So for your unsigned, the equation is 0 to the power of n minus 1. But now for the range, for the signed number, you have to the minimum is minus 2 to the power n minus 1 until this is the range. The upper bound is 2 to the power n minus 1 minus 1. So it's just playing on how you can apply, when is the situation you can apply to all this equation. So just play around with the equation. No need to like want to apply the knowledge of understanding. But still you need to understand which part is this scenario, which part is using this scenario. An example, you were given this one, this is the bit numbers, and you have the positive, you need to add 0 in front. And another example is you were given this number and you need to assign as positive, so you need to add 1. This one is at 0, so this is the result. So there is not over here, I think in your module and also ebooks, they already mentioned also about this. A negative number has the same magnitude bit as the corresponding positive numbers, but sign bit is 1 rather than 0. So this is the example. Integer 4 bits. You were given 4 bits, and because of this, you're going to apply this equation as to get the range, minimum, and this one is the maximums for the range. And the equation what? Minus 2 to the power of n minus 1. So minus 1, which is n, we're going to change it to 4, you get this one. And this is the range. And positive 2 and minus 1 minus 1. And then you get this as you replace n with 4. So now, after that you have minus 2 to the power of n. This is just calculation. You can do it by yourself. And over here, this is the example, the maximum and minimum value. This one is for the positive side, and this is negative side. You can see you just add the value of 0 in front as to be positive. You just change it, the positive to 0, and over here negative, you change it into 1. Another example, which is express the decimal number from positive 25 and negative 25 as a 8-bit sign. So you were given this as for guide whether how many bits that we're going to write. So over here, what is plus 25 in binary? So you will get 10011. But as it's already informed you it is 8 bits, so you're going to add another 0. Should be there is another 10, but it's okay over here. Then you will add it as a 0 over here, as this is sign bits. This is a magnitude bit. And another one example, this one is on the negative bits. Over here you have negative, the positive is 1010 1001100. So you add this one to be 1. Should be, this is here. So like this. I think because this one is 8-bit, I think this previous slide is miss 10 over there. So now we're going to go into the complement numbers. So later on, if you did not understand about this, we will learn and discuss it in our class. But I think for this week, we going to have the Q&A session only in our online class, because we need to jump as soon as possible to our lab 1. So this is under complements of a number in base B, which is whether it is 0, 1, 0, 10, base 2, base 10, and etc. We can compute 2 complement. So what is the complement? Is first complement and also second complement. For the binary number, we can use 2 complement. And for decimal, we can have 9 complement and first complement. Sorry, this bit number, we have 2 complements and first complement. But what we're going to look is only for binary number. We're not going to look into decimal arithmetic. So that's why we're going to focus on first complement and second complement for binary number. Here is the first complement. How are you going to get it? Convert 0 to 1 and 1 to 0. This is the method. You have the method which is for the first complement. You're going to change everything in your number given. You're going to change 0 to 1 and 1 to 0. If let's say you were given this kind of number, what is the first complement of this? You get 0, 0, 0. Let's say you have 1, 0, 1. What is the first complement number? Is 0, 1, 0. Because of what, you're going to change 0 to 1 and 1 to 0. But this one is applied only for the negative. So this one is the lower bounds and this one is upper bounds. Is quite similar. where n is total of bits. And here you can see the example here. You have this number 11010 and you are given it as a positive. So you will put it as like this and positive over here, and you will add 0 here as positive number. You can see you're not going to apply this one as this is positive number for first complement. If you were given the positive number and you're going to change it into first complement, it's going to be similar, only you change it in front, positive or negative. Nothing happened inside the number. But when you deal with the positive number, what you need to do is you need to change it. Let's say assume that you have this number and it is 7 bit, 1 2 3 4 5 6 7, and it is a negative numbers. So you need to change it all to 0 to 1, 1 to 0. So this is 0, you change it to 1. This is 0, you change it to 1. This is 1, you change to 0, 0, 0, you change this 1, 1. And then you get 1, 0, which is 0, 1. This is how you change it for the negative numbers for first complement. So this is the example table that you can use, and I give you the example for negative 7. You need to find the answer for first complement for this number. First of all, you're going to do that 111 is referred to 7 and there is negative in front. This one is for bit, if you can see over here. And what you're going to do is this one, you will directly change everything. If it is 1, it will become 0, 1, it becomes 0, 1, it becomes 0, and 0, it will become 1. Where is it? Where is it? What happened to here? You can see there is a difference. If it is positive numbers, you need to assign the value, isn't it? Positive, it becomes 0. When you talk about negative, you're not going to replace it with 1 as in the sign number. That is what I mentioned. It's quite and a bit confused. But if you hear it clearly and you follow its sequence step by step, you will see there is a difference. So you can see in your sign number, you will add 1 in the MSP if it is negative. But for the first complement, there is a but, for the first complement, you will just apply this method. So you have this number and this is negative number. So you just apply this one as represent is negative value for first complement. So I repeat again. This example is for positive number. What is going to happen? But this is only for first complement. If let's say the question asks you, you were given this number, please get the first complement of this number. So you check first, oh, this is positive number. What you're going to do is you will apply this number similar, but this one is there is a positive. Positive is 0. That's why you will add this 0 in front. This is the case for positive number. and then you were given this number. You learned in the previous slide, if it is signed number, not first complement, okay? Signed number, you're going to change this number. Let's say you have 100, 100. If there is negative, you're going to change it into 1. So you get the answer for your signed number. You get this. This one is for your signed number, isn't it? But this one is for your first complement. You were given this number and you will take this, put it here, and you look into over here. Oh, this is negative. Then you need to apply this one. So you apply this one in here. So you change it, you're going to get 101. Isn't it? I change it accordingly. 1 1 0 1 1 0 1. Yes. So this one, why there is a 0 in front? It is because over here it just assume, let's say in question you were given 7-bit binary system, but the answer, if let's say just straightly from this number, it is 100 100. I didn't convert it correctly. Sorry. Let me start again. This one I change it directly, okay, to below, so I can see it clearly. You apply this one, you get 110 110. So this is the answer if you just directly convert using this for your first complement for assign it as negative number. But if let's say in the equation is mentioned it is a 7-bit binary system, you need to know that you have another one. If let's say you have another one, you need to complete all first before you can apply this method. So if let's say you mentions that it is a 7-bit binary, so you need to know there is 7 supposedly, 1 2 3 4 5 6. So there is another 10 in front as to complete it as the 7 binary system, and this is negative number. So for after that, for negative, you're going to apply this. That's why you will get 10 Same goes here. Okay. So please try to convert it all by yourself and try maybe 70, 60, 50. This one is quite easy because you just add 0 in front. But how about negative? For first complement, let's say you try negative 10, negative 20, negative 30. Try it by yourself how you're going to get the first complement result number. Over here, let's say we move into our second complement, which is this one is second complement. So you can try this example. And second complements, if you check it, what you need to do is first you convert it into first complement first, then add to 1. It's quite simple, alright? You just need to know the method and step on first complement and just add 1. Then you get the answer for second complement if you were given the numbers. similar to here, you get the answer similar to the previous example. And the second step, you need to add 1. This one, this is the example from positive side. You get over here, this is the result. But this one, if let's say you are playing around with negative number, you need to move it to the first complement first. So this is the one that you get in a previous result. Then what happen next is you need to add this number to 1. Then you will learn on this method. Where is the method over here? Okay, I just show you here also can. Let's say you were given this answer. This example already been discussed in the previous slide. So you get the number of 1 0 1 1 0 1 1. Okay, over here, this is the first complement. This one we already tried the example. Then how you going to get the second complement? For negative value of number, you will plus 1. So how about the process? You need to know that there is a table. When you add 0 0, you will get 0. 1 0, you get 1. 0 plus 1, you get 1. But 1 plus 1, you will get 1 0. 1 0 in binary, it is 2. Is it okay? Not 10 over here. This is not 10, but this is 2. In decimal, this is in binary form. So that's why 1 plus 1, you get 0, and you will put 1 at top over here. 1 plus 1, get 1 over here. This is how you adding. So you get the answer for your second complement. Let's look into another example. This one, this integer 4 bits. As I mentioned, positive, there is no problem for you. But in negative, you need to do first is you need to find the first complement first. Then for second complement, you add 1. Let's say over here you have my negative 0 0 1. So you convert it, you will get 0 1 1 for the first complement. And then from here, this is the first complement, because you change 0 to 1 to 0, 0 to 1, 0 to 1. So you get first complement 1 1 0. And for second complement, you will add this number to 1. So you add here with 1, you get 1, and then 1 1 for 1 1 for the first complement. And over here, why that? Oh, because of this one is the 4 bit. I forgot about this. So for 4 bits, suppose I will be having 0 in front. Let me do it again for this example. Forgot that there is a 4 bit. 0 1 0 0, and because of its 4 bit. So this is how it's going to look like, isn't it? Supposedly. That's why after that I directly convert it into the form of first complement. And then this is my first complement. I directly change it into the method using 0. I change it 1, I change it to 0, 0 I change to 1. So I get my first complement. After that, I add it in with the 1. So I get 1, 1, 1, 1. Simple. So there is also example on -7. First of all, because this is a 4 bits, what you need to do is you need to add 0 in front, 0, 1, 1, 1, and then this is negative value. After that, because of this is negative, you need to do the first complement method, which is if it is 0, you change it into 1. If it is 1, you change into 0. 0, 0, 0. This is first complement. After that, you add this one with 1. So you add, you get 1, 0, 0, 1 for the second complement. Quite easy. Please try it. Do it by your own, and maybe you can try -10, -20, -30, and so on. So please try to do this example also. This one is quite similar. You were given 7 binary system for first complement, and then you need to compute the -23. So for 23, this is the value 0, 0, 1, 0, 1, 1, 1. 1, 2, 3, 4, 5, 6, 7. Because of what? This is 7-bit binary. I'm too lazy to calculate using the calculator. That's why I take it out from here. And there is a negative in front. Because of this is negative, you're going to apply the method. How are you going to apply? You just change 0 to 1, 1 to 0. So you get this answer for your 7-bit binary system for your first complement, and then you just add with 1. You get the second complement. Easy peasy. So now exercise 2, you can try it by your own, I think. Similar also with this table. Quite easy because we already do and done it before this. Just fill it. And this is the table that I mentioned. If you have 0 plus 0, you will get 0. If you get 0 with plus 1, you get 1, 1, and then you get not 10, but it's 1, 0. And in the value of decimal, it is 2. This one is binary form, and this one is decimal. So I think you can try this example by your own, quite similar. And now, after we already done on the adding, we look into subtraction. So in subtraction, it is just a deduction, a method, and process. Similar also quite on the mathematic form. So what you need to do that in digital system, subtraction is performed by using second complement. So don't do first complement in the subtraction. So you will use only the second complement and do the adding process. Carry from MSB sign bit is deleted. So all the MSB will be deleted after the process of this one. So you were given the example. You have 0, 1, 0, 0, 1, 1. You want to minus it into 0, 1, 0, 0, 1, 1, 1, 1. So what happened over here? Can you deduct it directly? So what happened is you cannot minus it using this system. That's why you're going to change first of all these deduction number to the second complement. Or you pick it as the negative value. What happened here is this number, you just let it similar. This number, you just drag it over here, and this one is similar to minus, similar to positive, negative value of the second number. That's why you get like this. So if it's a second negative number, what you're going to do? Negative number, you're going to just deduct it. But you need to know subtraction. You cannot just use this value to subtract. But you need to subtract the value of negative for second complement. I give you the example. If let's say you have 0, 1, 1, you need to minus 0, 0, 1. So maybe like this. So what happened? You cannot do this. 0, 1, 1. You add negative. This one is let's say 0, 0, 1. So what happened? You cannot using the sign method, which is, if let's say sign method, you're going to change negative to be 1 in front, isn't it? So you cannot use this. And if let's say over here you have 0, 1, 1 plus negative 0, 0, 1. So over here, if let's say negative, you cannot just using this value. If you change it into first complement, you will get 1, 1, 0. So negative will be like this. So you will get 0, 1, 1 plus 1, 1, 0. This method also you cannot use. So I show you what method that you cannot use, which is sign method, and also first complement method you cannot use. But what happened is, if let's say you have the subtraction, you need to convert this number to be first complement. Then you just add. So first, what you're going to do is like this step. This is negative 0, 0, 1, 1, 1, 1. What happened? You will, I put it here, 0, 0, 1, 1, 1, 1, negative. So you're going to find the first complement first. So what happened? You will change it into 0, 0, 0, 0, 1, 1. This is the answer for first complement. And after that, you're going to change it into second complement by adding 1. Just add 1 over here, you get 1, 0, 0, 0, 1, 1. That's why you come up like this. Then you just add using the same adding operation. Just add. If it's 0 plus 0, you will get 0. 0 plus 1, you get 1. 1 plus 0, you get 1. And then 1 plus 1, you get 0. So there is example. You might also try by your own, because it's quite simple. Just change into complement and add it. until end of this slide. So that's all for your arithmetic operation system. So thank you for watching, and we're going to look into the next video after this for the new module, which is module 3. Thank you and bye bye.